Misty analysis aims to match different seismic surveys. For example, you can match 3D with 2D or 2D lines with 2D lines. Seismic mismatch is commonly attributed to several reasons, such as different processing techniques, different time acquisitions, and type of vintages. Imagine yourself as a seismic interpreter intent to work on seismic datasets produced from different vintages, and these vintages were acquired with varying parameters and processed differently. So Misty analysis is crucial before going to seismic interpretation. So what are the types of Misty analysis? There is a vertical Misty, which corrects vertical Misty between seismic lines. There is a gain Misty, which matches seismic lines based on amplitude differences, or in other words, it balances the amplitude differences between seismic lines by applying different sets of gains to normalize the display. There's the third one, which is the phase Misty. It's like when you have two wavelets, one is zero phase and the other has a rotation value. So you can extract that phase rotation value for every line in relation to the respective cross points. So how to do Misty analysis in Petrel? First we go to the 3D seismic, right click and go to insert Mistype Set. So in this window you determine which survey you want to do Misty analysis. If you picked only 2D, Petrel will run the analysis between the 2D lines only. But if you picked both 2D and 3D, Petrel will do Misty between the two surveys, and this is what we want to do in this exercise. So I choose both, okay, and click OK. Now this window is called the Misty Manager. This window displays the intersection between 2D and 3D lines. So for example, we have the line 8, which is intersected by 5 lines, which is line 5, line 1, line 2, line 6, and also the 3D survey. The Misty Manager will calculate four parameters. The first one is the vertical Misty, which is the vertical shift between the two lines, like a line 8 and line 5. This is what we will compute. And second, the correlation factor, which reflects the confidence. Whenever the number is close to 1, it means that confidence is high. But if the factor is small, like 0.7, 0.6 or 0.5 or smaller, then confidence is low. Therefore, it's better to neglect this line to avoid distortion of seismic, and that's by going to the lock cell here, and you click on it to deactivate the line from the correction. Then we have the vertical correction and vertical residual. The vertical residual column indicates the quality of computed correction, which is the difference between estimated vertical Misty and the vertical correction. However, high values indicate intersections where Misty is still high after correction. We will see that next. Now let's come to the source. Our only source in this exercise is seismic, but if you have a horizon, a certain horizon, take it and drag it to this space, and the analysis will be carried out at this horizon level only. But we will come back. We don't have the source as a horizon. We only have the seismic now. Now we will work on this part, okay, to compute the vertical Misty and the correlation factor. So in the fixed interval, we set the top and the bottom of the reservoir zones, and in this exercise, the -250 and -2500. And you can also select a reference horizon here, okay, if you have a reference horizon, and you can set the window size from this cell. Now, then we come to the type of analysis that we want to apply. So we have the vertical, phase, and gain. So if we choose vertical, then the Petrel will correct the vertical shift between between each two lines, like line 8 and line 5. For if you choose gain, this will enable the correction of amplitude balancing for 2D and 3D surveys. For face, it will do the face correction for both surveys, 2D and 3D. But in this case, okay, you can choose the three together, or only one of them. So in this case, I choose only vertical. This is what we will do in this exercise, and click compute. Now we computed now we computed the vertical mistype, which is the vertical shift between each two lines, the correlation factor. Note the correlation factor values are very close to 1, 0.9, 0.8, all the way down, all the way down, and so this means that this indicates high confidence and good correlation between traces. This means that Petrel can do the shift, but remember, if it's smaller, like 0.7 and 0.6 and much smaller, then you need to come and count out these two lines out of the analysis by clicking on this cell under lock symbol. Now let's compute the vertical correction and the vertical residual from this part. So in the correction tab, if we choose variable correction, this will be done for each individual line based on its vertical shift value. Actually, this is not favorite, as it will make the inline gain zigzag pattern. So constant is the best choice, is the better option, as it chooses the best correction value. Then apply adjustment on the other lines accordingly. So I leave it constant and click compute. Now after I have finished, I click realize and make sure that everything is done correctly. Okay, I click compute, and when I come back to my 3D, I notice that there are two surveys of Misty appeared. Actually, okay, there is one appeared under 3D Seismic, and a copy of 3D Seismic Misty also appeared, which is the inline X line after the vertical correction was done. Now for preview and QC, there are two icons to the left side of the Misty Manager window. Okay, if you take the first one, it will show you the intersection between 2D, between the lines, okay, 2D, for example 2D and 3D before Misty analysis application, and the second one will show you the intersection after the Misty correction. Actually, this is faster way to preview and also to save time. So let's display the original Seismic 3D and 2D lines. Sorry, I think I made a mistake. There must be another version of Misty survey to be displayed under 2D. Maybe we need to come back to the Misty Manager and click realize again. Yes, okay. So we choose the realization quality. Okay, so I choose the integer 16-bit and click OK. Wait for processing to be done. Okay, that's good. Yes, that's what I'm talking about. Now we have the versions of 2D lines, which is after Misty analysis, and the 3D 3D Seismic after the Misty correction. Now I display my my 3D lines after correction. So I show a nice line. I go to 3D Seismic. I show the 2D lines after. Okay. Now, if I want to display the the match between the lines 2D and 3D before the correction, I come and click on this icon. Okay, so now let's choose 2 lines as candidates. Okay, I'm displaying the 2D line and 3D line survey after mistype correction. Okay, so let's come to this line, for example. Okay, now if I want to display the intersection between these 2 lines, okay, I come to this icon. There's a line, there's a line 8 and line 6, and display the shift before the correction. So when I click, you see that the line moved 1 step up. Okay, and when I click it, it goes back to the corrected location. This is before the application of seismic mistype analysis. This is after. Let's take another example. This one, no, not this one. Yes, this one. So again here, yes. So this is for correction. Okay, it was pushed a little bit up, but it's not that perfect. Yes, you can see how this at the intersection at this area, if you click on before the mistype correction, it goes up, it goes back to the original face, and if you untick it, it will bring it back to the corrected shift. Now, before we close Misty Manager, there's one point worth mentioning. Let's suppose that your 3D survey, or either of them, is the updated one, and you are sure about it, that this is the best quality, so you want to tie the other seismic lines to this survey. So what we do is that you come to the 3D survey, and come to the 3D survey, and you click on the lock next to next to it. Okay, and by this action you are telling Petrel to shift the other lines according to this survey. So this means that it will fix the 3D survey and shift the other lines according to it. Now, if you closed the Mistype Manager, but you needed to come back again to do some modifications, you come to the I think here you come to the Mistype Set, right click, and Mistype Manager. In case you want to do some modifications, or you want to fix some errors and so on. Now, suppose that you finished and later you want to come back to also, okay, yes, no. Now, after we finished mistype process, we need to see the correction values done so far on the map. In our work, this map is important to see where I have the biggest shift in the area of the reservoir. So, to create a map, we go to open map window, display 3D seismic lines. The original ones. And also the seismic survey, which is go to points from Mistype Sets. And click on vertical Misty absolute value. Okay, need to click here. Okay. Now these points where the vertical shift was done. Okay, so we go to make edit surface on process. Oh, I need to bring process panel. Okay. Okay. So I drag the points from Misty here, okay, and I choose vertical Misty absolute value. The geometry tab I click automatic. In algorithm tab I choose Kriging interpolation. We use Kriging interpolation to make a contour map. Now and click OK. Now this is the vertical shift map. So if we want to display the values on the map, so we go to right click on points from Mistype Set, go to setting, style, and number annotation. We click show, right here, click apply. Now these are the numbers or the values of the vertical shift done by Petrel between each two lines. From the legend, red color represents the maximum or the highest shift, while the green color represents the maximum shift. The red color represents the minimum shift. We can change the legend. Okay, from the come to the input map. Okay, right click, edit color. Red. We can make the red indicate the highest and the yellow indicates the smallest shift. Okay, and click apply. Now this is it. Now we have the red color represents where the red color indicates the areas where we have the maximum shift, the maximum vertical shift, while the yellow where we have zero match between each two lines. Okay, so there's another way to make 2D window map. Okay, let's close on these ones. Okay, so we go to open 2D window. We click on display Mistype Sets. Right click on any one of these points, okay, and go to this toolbar will show, and go to make edit surface, this icon, click on it, okay, and the make edit surface window will show again. So I keep all these inputs is the same, and the settings is the same, algorithm also is the same, which is Kriging interpolation, and click apply. Now this is my window appeared into the I hope that you learned now how to do seismic Misty analysis. and became familiar with Mistype workflow, besides how to map the Mistype correction values. If you gained a great benefit from this video, I appreciate if you hit like below the video and subscribe to my channel Geoscience Skills on YouTube. Thank you for watching and keep learning.